Good evening. Today we are going to discuss derivative as rate measure, where we learn how a quantity which depends on another quantity changes at a particular instant. This change may be time rate of change. This change may be change of volume with respect to radius, something like that. The meaning of dy by dx, as you got in class 11 syllabus, was that dy by dx means rate of change of y with respect to x. So if there is a term like ds by dt, what is the meaning of this? It means rate of change of some quantity s with respect to time. This s may be anything, it may be volume, it may be distance, it may be displacement, whatever. That how s changes with the physical quantity t, that can be discussed by calculating the rate of change of s with respect to t. Okay, so when you find dy by dx, in general this was just application part. ds by dt is applied in physical sciences also, but in mathematics when you say dy by dx or f dash x, it means it is rate of change of y with respect to x. And when we say that dy by dx at x equal to x0, it is rate of change of y with respect to x when x is equal to x0. If two variables x and y both depend on t, then rate of change of y with respect to x we calculate by using the formula we have already done, that dy by dx is dy by dt by dx by dt, kind of chain rule here, provided dx by dt equal to not equal to 0. Okay, and in this chapter two terms, marginal cost and marginal revenue, also will come to know that marginal cost will be the rate of change of cost with respect to the output of a company, and marginal revenue is the rate of change of revenue with respect to the output of a company. If we consider the simplest example, like suppose a problem is given this manner, that what is the change of area of a circle when its radius is given, say 3 centimeter, and the rate of change of radius with respect to time is given as 0.2 centimeter per second. Okay, so radius is given, rate of change of radius is also given. Your problem is to find the rate of change of area. So first we pose the problem, we write a equal to pi r square, then we differentiate with respect to t. If we differentiate with respect to t, then this is going to be, you all know the derivative of this term, that if we differentiate with respect to t, then this thing going to be dA by dt equal to pi into derivative of r square 2r, so it will be 2 pi r dr by dt. If you put those values given here, it will be 2 pi into 3 multiplied by 0.2 centimeter square per second. So this will be 1.2 pi centimeter square per second. This is the answer. Okay. Now the next problem, that volume of cube is increasing at the rate of 8 centimeter cube per second. How first is the surface area increasing when the length of the edge is 12? A cube, all of you know, it has length equal to breadth equal to height. Its surface area and volume both are well defined terms. So when you take a cube into consideration whose length of side is equal to a, then its surface area is, you know, 6 square its volume you know, a cube. Okay. Now what is given here that you have to write first? The volume is changing. It is given the rate of change of volume is given as dV by dt. dV by dt is going to be 8 centimeter cube per second, and age of the cube is a equal to 12. At this instant, how surface area changing we have to find. So what I am doing here, first I differentiate this relation to get the value of dA by dt. If we differentiate with respect to t, dV by dt going to be equal to 3 square dA by dt. This implies if we put the value of dV by dt here, this is going to be 8 equal to 3 square. What is the value of a here? The value of a they have told when it is 12. So it will be putting 3 into 12 square multiplied by dA by dt. Okay. So this will give us the result dA by dt, that is 8 divided by 3 into 144. Okay. So after getting dA by dt, we pay our attention to get the value of ds by dt. ds by dt going to be what? This is 12a dA by dt. If we substitute the value of a over there, that is 12, and dA by dt, 8 by 3 into 144, then you get the answer. Okay. So ds by dt can be determined if we know dV by dt and the length of the side at that instant. Now we are going to solve this one. A stone is dropped into a lake and waves moves in circle at a speed of, this gradually spreads out, from a droplet. It will be like this. Gradually its shape is increasing. I am not drawing all. Just imagine an arbitrary instant when its radius is equal to r. At the instant when radius of the circular wave is r equal to 8 centimeter and dr by dt, the wave travel with the speed of increase in radius only. So dr by dt will be 5 centimeter per second. You just find the value of area. Area at this particular instant will be pi r square. So differentiating with respect to t, dA by dt going to be what? 2 pi r dr by dt. Put the values over there. It will be 2 pi into 8 into 5. This is equal to 80 pi. Okay. So all of you understand. Let us go for next sum. That length x of rectangle increasing at the rate of 5 meter per minute and width y increasing at the rate of 4 centimeter per minute. X, y given, find the rate of change of its perimeter. So you pose the problem this manner. Length bed they have already given. You don't need to change any symbol over there. Perimeter P equal to twice x plus y. So differentiating with respect to t, of course, because it is given meter per minute. That time is minute over there. So if we differentiate, this is going to be dp by dt equal to 2 into dx by dt plus dy by dt. Okay. If I substitute the value of dx by dt here, the dx by dt is given. You all can do that. Rectangle decreasing, x length of rectangle is decreasing, y increasing. Decreasing means this part, that dx by dt has to be a negative quantity, decreasing at the rate of 5, so it will be minus 5 centimeter per minute. And dy by dt going to be what? dy by dt going to be plus 4 centimeter per minute. Okay, so this is going to be minus 5 plus 4, answer is minus 2. So your answer will be increasing or decreasing? That perimeter, obviously perimeter is decreasing at this state. So perimeter is decreasing at the rate of this thing. Okay, or you can ignore the negative sign over. If you are saying decreasing, no need to put the negative sign. You just write it is decreasing at the rate of 2 centimeter per minute. Okay, so all of you understand. Now another part is there, that when you are going to consider how the area of the rectangle is changing, the rate of change of area, when you are going to find the area part, that area you need to put this manner. For the second part you put a equal to what? How much? X into y. So dA by dt will be x dy by dt plus y dx by dt, and again we need to substitute those values. When x is 8, dy by dt given to be how much? dy by dt is 4 plus y is 6 and dx by dt will be minus. Minus means minus 5. So this is going to be 2 centimeter square per minute. It is increasing. This time it is increasing. That's why you get plus sign. All of you understand? Let us go for the next problem. Ladder 5 meter long leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is the height of the wall? Height on the wall decreasing, that we are going to find. This is the ladder. Okay. Now, how fast this thing going to change, that we are going to find. Which one going to change here? All of you can see that. This is the ladder AB. This is your wall where it is leaning. This is the ground on which it is leaning. Now, bottom of the ladder when it is at X, and this one Y. By your process, you have started here by pulling it down. The length of the ladder will not change. This L remains 5 meter forever. All of you understand? So there is one relation in the beginning which will help you, that x square plus y square is equal to 5 square. Number 1. The question is height. How much? How y changing? So we'll keep y on one side. If we keep y here, this is going to be 25 minus x square. Now there is given dx by dt. Dx by dt is given to be 2 centimeter per second. Your problem is to find dy by dt. dy by dt will be what? When x is equal to 4 meter. Okay. So what you are going to do there, just differentiate with respect to t. Dy by dt going to be minus 2x. This derivative all of you are familiar with, into dx by dt, and 1/2, sorry, not half, 2 will be there. So this is going to be 2 into this. So answer is minus x by root over 25 minus x square. So you just put those values, dy by dt will come out. Okay. The next one, when a particle moving along the curve, find the point on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. How will you answer this question? Here, just think. We are going to solve it in this manner. Point on the curve, y coordinate changing 8 times as fast as the x coordinate. So you will be putting that 6 into y equal to this. You just differentiate with respect to t. 6 into dy by dt is going to be 3x square dx by dt. Now it is given that on the curve y coordinate changing, given that dy by dt equal to 8 times dx by dt. So just use this condition, 6 into dx by dt into 8, 3x square dx by dt. So you cancel these two terms. From here, x is coming to be under root 16, that is 4. When x is 4, y is going to be 4 cube plus 2, 64 plus 2, 66 by 6, that is 11. This is the requirement of the sum. Just find the point. So required point going to be 4, 11. Alright. See you again. Thank you.